This is going to be an update on this sort of steerable pin walker I started last week and posted a video on. This is one I showed last week. It has the idea is to when the motor runs in reverse, one of the pins will stop driving and the thing will turn as the other one does turn it or does move in reverse. This one uses a magnetic slip clutch type mechanism and a ratchet and pawl to stop this leg from turning when it goes in reverse. I'll just briefly show that. It's controlled by just a universal remote and Sony 12-bit codes. Here's forward, stop, reverse. Stop. I did a whole video on that last week, so I won't show too much of that. I was pretty pleased with the way it worked. Could be better. But Robothut left a comment on the video telling me about a similar design he did 12 years ago where it would, when the motor ran in reverse, it would turn by. His used the pin on one side had a mechanism on the bottom, like the bottom of a leg, that would break loose. So when it ran in the opposite direction, it would not drive the toy in that direction. But when driving in the forward direction, the knee would lock like I guess you call it a knee, and push the toy forward. So I designed this one. Let me turn this one on and show it working. That's forward. And this is reverse. Works very nice. Show it, try to get it a little closer. Forward. Reverse. You can see it turning in reverse. Turning into a dead leg. The mechanism, he used a spring to kick this one way, and then I believe the weight of the toy he was building would keep it from driving in the reverse direction. This is a very light toy. It's only about 3 inches tall, so using the weight really wasn't working for me. I made a couple of attempts at it, so I went with magnets. There is a magnet here and here in the bottom part of the leg, and a magnet here and here. And when this leg gets close, it'll either kick it one way or the other, depending on the direction of a rotation. I'll show it up close. Forward. This is slightly over center to help it keep the knee locked as it drives backwards. In reverse. Works pretty nice. The other thing I did on this one, the other one had the controller is an A-Tiny 85 microcontroller with a L9110 motor driver chip. On this one, I just used a piece of perf board, and this has all these connectors removed and it's stuck on the back. That's what that is. For this one, the newer one, I took some of these, I believe they're called SOIC, or surface mount adapters is what they are. They adapt an 8-pin surface mount part to a dip 8 part. And I broke two of them off and left them together. You can see right here. Then I put my dip 8 socket on one of them and desoldered one of these, which that was a lot of fun, the L910, and soldered it onto here, and then just used jumpers to make the connections between the two chips. And it's kind of a mess on the back, but it works, and it's very small, which is what I was going for. Here's a little IR receiver. Well, the A-Tiny is programmed to respond to Sony 12-bit codes. It doesn't use a library or anything like that. It's just straight code written in the program. The other interesting thing about this, or I think it's interesting, is when it walks in reverse, you can see it. Even though this leg is up, it's still, this leg gives it a little kick in that direction, even though it wasn't planned on. It's just a happy accident. It's because this angle right here and the length of this is just a little bit long. It pushes it just a little forward when it's going in the reverse direction. Makes you wonder if you couldn't make a steering mechanism just from that alone, just by driving these pins straight up and down, of course 180 degree out of phase, and then having a bottom part of the leg that would kick one way or another by magnetic actuators or electromagnetic actuators. And maybe you could make a steerable robot like that. Haven't really thought about it and fleshed it all out, but I thought it was kind of interesting. That's one of the things you only find out when you're experimenting with things like this. You're probably not going to think of it when you're just sitting and designing things. Well, I want to thank Robothut for his suggestions. In the last video, he said he used a guitar spring on his. I didn't think I could get that to work, so I just used magnets. Well, that's it. Thanks for watching.